We will discuss today division of polynomials by synthetic division. So there are actually different methods of dividing polynomials, but one of the easiest method is the known synthetic division. So suppose we are given this problem. The negative or the quantity of negative 5x raised to 5 minus 21x raised to 4 minus 3x cubed plus 4x squared minus 2x plus 2, and we are dividing that by the quantity x plus 4. So if you are going to do the synthetic division in this process, what do we need to do? Okay, so basically the method of synthetic division is doing away with the variables. So as you notice, what we did is just copy the different numerical coefficients. So there you have negative 5, then there is the negative 21, there is negative 3, and then 4, negative 2, and then 0. So in the given, we don't have any problem because all the terms are complete. So if you are going to notice, you have x raised to 5, x raised to 4, x raised to 3, x raised to 2, and then x. And this is understood to have actually x raised to 0, but that turns out to be equal to 1. So 2 times the value of that, which is 1, is simply the constant. So again, we don't have any problem. Now, what if, for example, there is a missing term, like if this negative 21x raised to 4 is not existing. So there is a need to insert, okay, again, to insert a certain value of 0x raised to 4 if that happens. Now, you will observe also that you have x plus 4 here as our divisor. And what happened? We are now changing the positive 4 into a negative 4. So basically, we are looking for the 0 of the divisor. Okay? So that's the method. Again, we just copy the numerical coefficient, arrange from the highest or the numerical coefficient of the highest exponent down to the constant, and we divide by the negative of the or the 0 of your divisor. So in here you have x plus 4, so that becomes negative 4. Now, there are 3 letters that you need to remember in this solution. What are these letters? So the first one is B, which means bring down, and then A for addition, and then, or no, it should be multiplication first. May I undo that? Okay, it should be bring down and then multiply, and then after that we add. Okay, again, bring down, multiply, add. Okay, so these are the 3 letters that you need to remember. So we have now here your first term is negative 5, so we need to bring that down. We have negative 5, and the next step is multiply. So negative 5 times the negative 4. So that is equal to a positive 20. Okay, and then add, which means that we are going to add the result here. And of course, the answer that we will be getting is a negative 1. And then again, we continue. We have negative 1, multiply again with the negative 4. So we have now a positive 4. Okay, anyway, after the bring down, it will be a series of multiply, add already. Okay, and then again, we have to add this again. So we simply have 1, and we multiply once more. We have down the negative 4, which is the answer. And you will have an answer here, which is 0. Okay. And then when you multiply this negative 4 with the 0, of course, the answer that you will be getting is equal to 0. And if you are going to add this now will result to a negative 2. And having that, we have negative 4 times this will result to a positive 8. Okay? So the answer that we will be getting here is equal to 10. Okay, again, let's repeat. Bring down, so negative 5. Negative 5 times negative 4, we have a positive 20. Now we add negative 21 plus 20 is negative 1. We multiply the negative 4 with the negative 1, so the answer there is positive 4. Then we add again, that is giving us a positive 1. We multiply again, so we have now negative 4 times your 0, so that gives us an answer of a 0. And then adding negative 2 and 0, the answer that we have is negative 2. And multiplying the negative 4 with the negative 2, we have an 8. So we have here now equal to 10. Now let's remember that once you are dividing by a binomial, the last term that we have here pertains to the remainder. Okay, so this now, okay, refers to the remainder of your division. So this becomes the constant. This becomes the number with raised to the first power, raised to the second, raised to the third, and raised to the fourth. Now, if you want to start right away here, all we have to do is to take note. So this is raised to the fifth power, and then this is understood to have 1. That means basically you have to divide, or you are dividing x raised to 5 with x, so the answer is x raised to 4. So we don't stop here. We are now going to get the answer by putting back the variables. So again, you will now have negative 5 x raised to the fourth power, and then there you have negative x raised to the third power, and then this pertains to positive x squared. Okay, and of course, we don't have x because that is equal now to 0. So we have the negative 2 as a constant. So negative 2. And this happens to be a positive 10 being the remainder. You will have now 10 all over our divisor, which is x plus 4. So that is now how we answer, or how we solve by making use of your synthetic division. Okay, let's have some more examples. Okay, we have here now a polynomial with 4 terms, and then a trinomial, or a polynomial with 3 terms. So what happens if this is the case? Now, always remember that if you have a certain trinomial, there will be already 2 numbers that will be considered as your divisor. So again, we have positive 7 that will be changed to the opposite. So we copy, or we will just have the opposite of that, and that is negative 7, while the positive 24 here becomes negative 24. Okay, and then we have x raised to the third power, so that simply means that you have 1. 4x raised to the second power, so that means we have 2, and then you have 3, and there you have a negative 1. Okay, or negative 2. So it should be a negative 2. So again, there is no problem because this is raised to 3, raised to 2, raised to 1, and then your constant. So 1, 2, 3, and then, no, this is supposed to be 4. I'm sorry for that. Okay, this is supposed to be 4, this one. Okay, 1, 4, 3, and then negative 2. Okay, following now this method, you have to remember that unlike the other one, there is only one, okay, divisor. So this time you have 2 digits already. So there should be a wider space for this, okay, because we are expecting to have two fractions, or 2 layer as our product for multiplying the numbers that we will be getting later. So again, we continue. So we have Again, the process is you have to bring down, and then after bringing down, you have to multiply and then add. So we do that with this. So bring down 1 and we multiply. Now, in multiplying, there are 2. So there should be 2 answers also. So negative 24 and then negative 7 and then negative 24. Okay? So after having that, we will now proceed to addition. Okay, because we multiplied already the 2 terms. So we have now a negative 3 as an answer. So negative 3. Okay? So after having the negative 3, we do again the multiplication. So multiplying now your negative 3 with the negative 7, the answer that we will be having here is, what's the answer? Positive 21. And we have 24 with the negative 3. It's equal to positive 72. Now, this is where will we place that? Usually, okay, if you can actually write it here or directly below the 20, because there is no number that is written here yet. So we can write simply the answer for that, which is now positive 72. Okay, and then we go now to your addition. So as you notice, you have a 3 and 21 here, which actually results to a positive and then a negative 24. So there is a 0. Okay, and then if you are going to add this, the negative 2 with the 72, the answer that it will give us is 70. Okay, so how are we going to interpret our answer? Remember, we are now dividing by a trinomial. So the remainder should be a binomial, which means that the last 2 digits that the last 2 terms here pertains actually to your remainder. It's just that if you are going to notice this one, you simply have 0. Therefore, we simply have a constant 70. But if in case there is an x here, or like for example, this happens to be 2, this will become 2x plus 70. Okay? If this happens to be negative 1, then you have negative 1 or negative x plus 70. But since we simply have 0, then it will be just 70 all over this. Okay? So again, the last 2 is or pertains to the remainder. Now, why is that so important? Because you know you have to interpret this. So remember, this is x raised to the 3rd power being divided by x raised to the 2nd power. So this simply means that this pertains to x raised to the 1st power, which is now the difference of 3 and 2. And the negative 3 here is the constant. Okay, so if you do not know that this actually pertains to the remainder, you might think that these are the answers, like this will be the one with which is your constant, 1st power, 2nd power, 3rd power, which is not actually the case. So again, you have the last 2 digits or the last 2 terms pertaining to the remainder. So we have now x minus 3 plus, we just have to copy that 70 all over the denominator now, which is actually your divisor. So x squared plus 7x plus 24. Okay, so that is how we deal with division by trinomial using your synthetic division. Okay, let's have another case of applying your synthetic division. So let's have this. Okay, so as you notice, you have x raised to the 6th power minus 1, and then x squared minus x plus 1. So again, we are dividing by a trinomial. But try to look into the divisor. You have x raised to 6, and then immediately you have a constant. So there are actually terms which are missing. Okay, that means we don't have x raised to 5 down to x. Okay, so there is a need for us to insert 0. So again, the numerical coefficient of this x raised to 6 is automatically equal to 1. So we need to insert 0 for x raised to 5, another 0 for x raised to 4, another 0 for x raised to 3, another 0 for x raised to 2, another 0 for x raised to 1, and then we have the negative 1. Okay? Again, there is a need for us to have, this one is x raised to 6, so 5, 4, 3, 2, 1 before your constant. Okay, and we have the divisor here, which are x squared minus x minus 1. So again, this is understood to be negative 1, so that will be changed to a positive 1, while the positive 1 here is now equal to a negative 1. Okay, and again, the rule you have to follow, bring down, okay, bring down, multiply, and add. BMA. So bring down 1, and then multiply. We will have 1, negative 1. Okay, again, we have to add, multiply. So we will now have it diagonally. So 1, then I will just write the negative 1 there. So after having this, we have now 0, because you have a negative 1 with the 1, and multiplying that, you have 0, and then also a 0. Okay, we have a negative 1, so we write the negative 1, and multiplying that 1, okay, we have a negative 1, and then a positive 1, because a negative 1 with the negative 1 is positive 1. So we have to add 0, 0, and negative 1, so that results to a negative 1. And then after that, you will now have negative 1 with the 1 is a negative 1, and a negative 1 with another negative 1 is a positive 1. So we just have now your answer, which is 0 here, and then finally your negative 1 with the 1 here is also equivalent to 0. Okay, we are dividing by a trinomial, which means the last two terms here pertains to the remainder. And we know now that the x squared minus x plus 1 is actually a factor of x raised to 6 minus 1, because there leaves no remainder. So again, how do we usually have this? This is the constant raised to 1, raised to 2, raised to 3, raised to 4. Or simply subtract what is 4 minus the 2, that is equivalent, or 6 minus the 2, I should say, that will be giving us 4. So you start with x raised to 4, and then plus, you have x raised to the third power. It should be 0x raised to the second power, so we may not write that anymore. So we have now x simply for this one, and then of course the constant, which is a negative 1. So this is now the answer for your problem, x raised to 6 minus 1 all over x squared minus x plus 1. Okay? Now, what if you have observed that all the terms, the leading coefficient in the binomials are all 1? Okay? So there is no problem with it. But what if there is a certain case wherein you have, or you are dealing with a certain divisor with a numerical coefficient of 2 and not 1, or any other number except that 1. So like in this case, you have 2x minus 3. So again, in the synthetic division, the leading coefficient of your term must actually be equivalent to 1. Okay, that's one thing that you have to remember. So in that case, since our aim is for our leading coefficient here, 2x minus 3, to simply have your x, definitely you will be dividing this by 2, and you have to do the same thing with this, okay? Which means that this 2x minus 3 now will be, okay, dividing now your 2x by 2, that becomes now x, and then what you have is negative 3 over 2. Okay? So since we did this in the denominator or in the, what they call this one, in the divisor, we have to just do the same thing with our dividend. Okay, which means that we have to divide this by 2, we have to divide this by 2, and we have to divide this also by 2. So that's basically the practice once the numerical coefficient of your variable here, or the leading coefficient, is not equivalent to 1. Okay, so if you did that, if you are going to do that, that will result now to 3x raised to the second power, and then minus x, because 2 over 2 is 1, but you have a negative there, and then plus 2. Okay, and again, you are going to divide this by simply your x now minus 3 over 2. Okay. So again, the rule, we just have to copy. So we will have 3, and then that is raised to 2, raised to 1, and constant. So we only have a trinomial being divided by a binomial. So we have now your negative 3 halves will be equivalent to 2/3. Actually, you can write your 3 halves here or here, anywhere you want. So we can now have 3 over 2. Okay, so again, we follow our method. We just have to bring down 3, multiplying now 3 over 2, and then doing it by 3 over 2 times 3. That will definitely give us 9 over 2. Okay, so 9 over 2 added to 1 are negative 1. Remember, you have to change this to negative 2 over 2 so that they become similar. And therefore, that gives us an answer of 7 over 2. And multiplying now 7 over 2 with 3 over 2, the answer that you will be getting is 21. Okay, 21 over 4. Okay, if you want them to be similar, this 4 or 2 now will be renamed as 8 over 4. Okay, so 8 and 21 now becomes 29. So 29 over 4. Okay, so that means that we are dividing by a binomial. So this 29 over 4 pertains to what we call the remainder. So how do we do that? This is the constant. This becomes the x, or 3 raised, or 3x, because that is x squared divided by x. So 3x plus 7 over 2. Okay, your constant is a fraction, plus again the 29. Okay, if you are going to write this, this is actually 29 over 4. Okay, 29 over 4 all over your divisor, which is x minus 3 over 2. Okay, so that means to say you have to deal with this whole thing, because this is now in terms of a complex fraction. So basically, when you are working with complex fraction, you consider now your 29 over 4 as our divisor, and you are to divide this by the quantity x minus 3 over 2. So if you are going to combine this, we actually have 2 times x is 2x, okay, minus 2 divided by 2 times 3, so that is equal to 3, and then over 2. Okay, so if you remember how do you divide fractions, so you just have to copy the first term, and then you have to change the operation to multiplication. So I will be using the dot for the multiplication, and then 2 over 2x minus 3. Okay, so with the cancellation process, we can actually remove the 2 here with the 4, making this one equal to 2, and then we have now 2 as equal to 1. So that this simply means that the simplified form for this, okay, the simplified form for that is 29 all over, we can now multiply 2 times 2x, so that will become 4x. And then we have 2 times the 3, which is, or the negative 3, which is now equal to negative 6. So again, you are going to have that added to 3x plus 7 over 2 plus 29 all over 4x minus 6. Okay, we can actually check that making use of our long division, though I discussed that in another video. We will try to prove if we are really getting the correct answer for this, making use of our long process. So let's find out. We have 6x squared. Anyway, this is just short. 6x squared minus 2x and then plus 4. Okay, and we are to divide that by 2x minus 3. So we just keep the divisor. So we have to divide this by this. So answer is equal to 3x. And if you are going to multiply, that will now result to 6x raised to the second power. And of course, you have the negative 3 multiplied by the positive 3x there. The answer is the negative 9x. Okay, so the rule says that we have to subtract. So subtracting 2x minus 7, 9, because this is understood to be cancelled. So the answer is 7x. And we have plus 4. Okay, and divide 7x by the 2x. So definitely the answer that you will be having there is simply positive 7 over 2. Okay, because the x now are cancelled. So 7 over 2 multiplied by 2x, that results to 7x. And then you will now have negative 21. Okay, that is 7 times negative 3. So that is negative 21 over the denominator, which is 2. So from here, you have now 4 plus, okay, this is minus the negative of 21 over 2. So the answer that you will be getting here is, again, 29 over 2. Okay, 29 over 2. So if you are going to write that, this actually becomes plus. So this 29 over 2, okay, 29 over 2 all over 2x, 2x minus 3. So what do we do here? So if you are going to look into this, you have to multiply it by the reciprocal of this, which is 1 and 2x minus 3. So therefore, it will result to that 1. So again, that becomes also 29 all over 2 times 2x, that is equal to 4x, and 2 times the negative 3, the answer is negative 6. So we can compare that we are getting the same answer whether we are using the synthetic division or the long division method. That's how you divide, making use of your synthetic division.